Hello everyone and welcome to my channel. Today we look at differentiation. There are three topics: differentiation, integration, and area approximation that are so much related. So we need to look at them step by step, and we start with differentiation. I've worked out examples of each and every part explaining all the concepts that you need to know in this area. This is an area which you are supposed to be very much prepared when you are sitting for our KCSE, especially for the candidates. Thank you and hope you enjoy. If you are here to subscribe, kindly subscribe. Enjoy the lesson. So we'll start by knowing how to differentiate. So I have examples of how we are going to learn on how to differentiate. So for example, we talk about the derivative or the gradient function when you are finding or differentiating the function of y. For example, y is equals to n to power a. So we are supposed to multiply a by the coefficient of n, which for this case is 1. So that we have an 1 times a, then n a minus 1. So we subtract the power with 1. And that's now the differential function or the derivative of the gradient function. Another case, y is equals to 2x to power 3. So we find dy dx. So 3 by 2 and then x 3 minus 1. So the power is less by 1. So we have x 6x squared. Another case, y is equals to 3x squared plus 2x plus 3. So we multiply 2 by 3, 2 by 3, then x 2 minus 1, the power less by 1. In the second case, it is 2 by 1, which is the power of x, then x 1 minus 1, which is 0, then 3. This is as if it is to power 0, so 3 times 0x 0 minus 1, and then we have 6x to power 1 plus 2 to power 0. Anything raised to power 0 is equals to 1 plus 0. All that becomes 0 because 3, anything multiplied by 0 is 0. So therefore the answer will therefore be 6x plus 2x. A last one, we have y is equals to 2x to power 4 plus 3x squared plus 1. So dy dx, so we take 4 by 2, we get 8. 4 minus 1, we get 3 plus 3 by 2, 6x, 2 minus 1 is power 1, and the constant becomes 0. So that's how we differentiate. So let's look at differentiation, the first part, which tests on the gradient of a tangent and the gradient of a parallel line. So the equation of a curve is given by that function. Find the gradient function of the curve and its value when x is minus 2. So we are supposed to differentiate this to get the gradient function dy dx, like we said. So we have 3x, so 3 by 1, 3x, 3 minus 1, that's 2, minus 10, 5 by 2, x to power 1 plus 2x. The constant becomes 0. So substituting x being minus 2, we'll get the gradient function dy dx will equal to be, or will be 3 minus 2 squared minus 10 by minus 2 plus 2. So that we have 3 by 4. This minus will become plus 20 plus 2. So 14, oh no, 3 by 4 plus 20 plus 2. We get the answer to be 34. So 34. So we have applied the gradient function, or the way how to differentiate to find that. Determine the equation of the tangent to the curve at x is minus 2. So we are going to get the equation of the tangent when y, or y when x is minus 2. We first find that point because they share that point with the tangent. So we substitute minus 2 to the equation, to the original equation, to get the value of y, and we have, or we get that point, and that common point is the point the equation and the tangent share. So we have 8 minus 20 minus 4 plus 9. 8 minus 20 minus 4 plus 9, we get minus 7. So the common point being shared by the two, the gradient or the tangent and the curve, is actually point minus 2 minus 7. And the tangent and the curve share a common gradient, because the tangent is a point which just touch the curve at a point. They share a point minus 2 minus 7. So therefore we are going to use the gradient we got earlier, that is 34. So we are saying minus 2 minus 7 is the shared point, and the gradient is therefore 34. And we are going to apply the dy dx is equals to m. So y minus minus 7 divided by x minus minus 2 is equals to 34 over 1. So we cross multiply and get y plus 7 is equals to 34 into x plus 2. So y plus 7 is equals to 34x plus 78. Putting like terms together, y is equals to 34x plus 71. So that is the equation of the tangent to the curve at the given point. So find the equation of the normal to the curve at x is minus 2. So the normal, or the product of the gradient of the tangent and the normal, should give you -1. So these are concept in form 1. Form 2, gradient or equation of a line. So 34 by m2 should give us -1, and therefore m2 is equals to -1 over 34. So y minus the same point that we got earlier is the point where we have the gradient and the normal making, or the tangent and the normal making. So we find that y minus minus 7 divided by x minus minus 2 is equals to -1 over 34. Cross multiplying, we are now getting the equation of the normal. Then we open the brackets, we put the like terms together. So we get this 238 is equals to negative x minus 2. 34y is equals to plus 238 is equals to minus x minus 2. So we put the like terms together. (34y plus x is equals to negative 236. We can leave the equation at that point because no one has asked us to give it in the uniform. The value of x at the turning point of the curve. So at turning point, dy dx is 0, or the gradient of a curve is normally 0. The turning point. Therefore we are going to use the equation of the gradient where we said dy dx is 0 and we equate that to 0. The very first equation we found on the top there. So we can use the quadratic formula. So we are talking about the equation of the gradient equated to 0, since at turning point the gradient is equals to 0. So plus minus b, so therefore it becomes minus plus 10 plus or minus b squared 10 squared minus 4ac, so minus 4 by 3 by 2, divide by 2a, so divide by 2 by 3 to get the value of x. So it's gonna be either negative or positive value. So this is 100 minus 4 by 3 by 2, 100 minus 24, then 10 plus or minus the square root of 76 divided by 6. So we get the two answers, one which is positive, the other one which is negative. So inserting that in the calculator very fast, then dividing by 6, we get the first answer as 3.119. So we round that to 4 significant figures and you get 3.120, or we substitute, or we talk about 10 minus the square root of 76 divided by 6. We move on and now we look at the stationary point. Find the coordinates of the stationary point of the curve, and under this area we're going to look at stationary point and turning point of a curve, and also curve sketching. So in this case we have find the coordinates of the stationary point on the curve given by that equation. So we say that stationary point, the gradient is equals to 0, or at stationary point dy dx is equals to 0. So therefore we are going to differentiate the equation given and equate that to 0. So on differentiating this we get 3x squared minus 3x. So 3x squared minus 3 is equals to 0. and factoring out or taking 3 to the other side, we have that x squared is equals to 1, and therefore x will be the square root of 1, and therefore x is equals to plus or minus 1. So because we are looking at the stationary point, we are going to try when x is 1 and when x is negative 1 to find the value of y, so that we get the coordinates of the turning point. So from how it stands, the stationary point are 2. So substituting when x is 1, y will be what? So using the original equation, we substitute x being 1, so 1 cubed minus 3 times 1 plus 2, we get that y is equals to 1 minus 3 plus 2, and that y will equal to be or will be 0. So one turning point or one stationary point is therefore 1 0 1 0 1 0. So this is a turning point or the first turning point. When x is a negative 1, what will be the value of y? Again, we substitute y being negative 1. So negative 1 cubed minus 3 by negative 1 plus 2. These will be negative 1 minus or plus 3 plus 2. And that we find the value of y being equal to 4. So therefore the point will be negative 1, 4. The second stationary point or the second turning point, like we said earlier, this graph has 2 turning points. So, and we have identified the point. So we are going to save that for curve sketching later. Then for each of the stationary point, determine whether it is a minimum or a maximum. So we conduct the test whether it's a minimum or a maximum. So we start with the first point. When x is negative 1, is this a minimum or is it a maximum point? So the nature of a turning point is determined by its gradient. So when the gradient runs from negative through 0 to positive, then we say that's a minimum point. So when x is 1, so we are going to have values of x, and x to both sides, both the left and hand side and the right hand side. If we go to the right hand side, we have 2. To the left hand side of 1, we have 0. So we are going to conduct the test on the gradient. So automatically we know the gradient for x is 1 is 0. So we test for x is equals to 0, and we using the equation of the gradient. So 3 into 0, or 3x squared minus 3 is the equation of the gradient. So we substitute the value of x being 0, and then we see the nature or the sign of the gradient. So substituting x is equals to 0, we find that the gradient is equals to negative 3. So therefore the gradient of when x is 0 is actually a negative 3, and it is a negative value. So the gradient runs from left to right. So when x is 0, we already know, so that's flat. And when x is 2, now we talk about, or we substitute the value of x being 2 to the same equation of the gradient. Dy dx is equals to 3 into 2 squared minus 3. And you get this as 12 minus 3, which is 9. 9 is a positive value, so the gradient is 9, runs from right to left. So the gradient has changed from negative to 0 through 0 to positive. Therefore, it means the turning point is a minimum point. So the turning point at 1, 0 is a minimum point. And the gradient, or since the gradient changes from negative through 0 to positive. It's negative 0 through 0 to positive. Then the next point is when x is 1. So again, to the neighborhood of 1, we have, or when x is negative 1, so to the neighborhood of 1, we have 0 and negative 2 on the left. So what is the gradient of the line when x is equals to negative 2 and when x is 0? So we test with the equation of the gradient. Dy dx is equals to 3 into negative 2 squared minus 3, and we get 9, which is a positive value. So therefore, the gradient runs from right to left. And then dy dx when x is 0, we had seen that earlier, the value will be negative 3, meaning the gradient runs from left to right. And that point, the gradient is equals to negative 3, since 0 minus 3 is minus 3. So again, this is a negative value, so the sketch or the nature now is clearly seen to be a maximum point, because the gradient is running from left to right. A line whose gradient is negative is always running from left to right. Like for example, the gradient of a line when you talk about y is equals to negative x. So the nature of the turning point, or the nature of this turning point, is a maximum point. So the turning point at negative 1, 4 is a maximum point. And that is its shape, and the gradient changes from negative through 0, or changes from positive through 0 to negative. And that question stand answered. So finally, it is on curve sketching on this area. So for us to sketch a curve of the equation given, so we have an axis there. So there are things we are supposed to have for curve sketching. We are supposed to have the turning points, and we have already identified them. Then we are supposed to know their nature. Are they maximum, minimum, or point of inflection? And then we are also supposed to talk about the intercepts. So key points to note, I've said it's the turning points, the intercepts, both the x and y. At times we find that we don't require both. We'll see how and when. So now we have the axis and we have the turning points, and we know their nature. So the one of the turning points is negative 1, 4. We brought that. So that is the point. And it is a maximum point. So it will take that shape. The other turning point is 1 0 1 0. Here we have it 1 0, and it is a minimum point, so it will take that shape. So the next question to ask ourselves is the intercept, or the y-intercept. So the y-intercept, or the value of the y-intercept, is when x is equals to 0. So we are going to take the equation and substitute the value of x being 0 to find the value of y. And at that point, that is where we are going to have the intercept. And in this case, the graph will pass through 2. So therefore, we join our two turning points, and there we go. And there we have the equation, or we can write the equation on the curve, and we have sketched the curve. So that's how the graph would look even if it was plotted using the accurate way of plotting. So we move on to the application of differentiation. So we have a question here given by s is equals to 40t squared minus t squared plus 3t plus 3. So down that way, SVA, we differentiate. So we are required to find the equation for velocity, and therefore we are going to differentiate the equation of displacement to get 40 by 3, which is 120 minus 2t plus 3. And then we substitute the value of t when t is 3, and we're going to get 120 into 3 squared minus 2 times 3 plus 3. We get the value of v to be 120 by 9 minus 6 plus 3. We get the value of velocity being 1077, and this will be meters per second. The SI unit of velocity. The value of t when the velocity of the particle is 4 meters per second. So we have the answer of velocity. So we are going to equate the equation for velocity to the given velocity. And we find that this will give us an equation, or a quadratic equation, which we are supposed to solve quadratically using either factorization, completing square, or even the quadratic formula. And we go for the quadratic formula maybe for this case. And we have minus b, and in this case we'll have plus 2 plus or minus the square root of b squared. So minus 2 squared is b squared minus 4 is c, minus 4 by 120 by negative 1 divide by 2a, or divide by 2 by 120. So this is plus 2 plus or minus, so 4 minus, it's actually not 4 squared, it is 2 squared, the sign goes, so minus 4 by 120 by negative 1, we get 484. The square root we divide by 240, or 2 by 120. So 484, the square root is 22. So we have 2 plus or minus 22 divided by 240. So we are going to get two values of t. So 22 plus 2 divided by 220, 240, we get 1 over 10. So t is equals to 1 over 10 seconds, or when we take the negative sign, we have 2 minus 22 divided by 240. We have negative 1 over 12. But we cannot have the value of t being negative. So we will go for the positive value and talk about t is equals to 1 over 10 seconds. So the displacement when the particle velocity is 4. So s. So in this equation, it's only t that we are going to borrow, because the time when the velocity was 4 meters per second, the time was equals to 1 over 10. So 40 t cubed and minus t squared plus 3t plus 3 was the equation for displacement. So we substitute the value of t being 1 over 10. And we have 40 by 1 over 10 cubed. So we are talking about the velocity when the displacement when the velocity was 4. So we are using its time then. Plus 3 by 1 over 10 plus 3. So 1 over 10 cubed times 40 is 1 over 25 minus 1 over 100 plus 3 over 10 plus 3. So answer plus minus 1 over 100 plus 3 over 10 plus 3. So we get 3.33, and we write that in fractions, or at times it is best way. We can give the answer if it is terminating. So 3.33 meters, that is the displacement. So the acceleration of the particle when t is 3. So acceleration is given by dv dt. When you are moving from velocity to acceleration, we are supposed to differentiate the equation for velocity, and therefore we are going to differentiate that equation we found earlier for velocity to get the equation for displacement. So the 12t squared minus 3 or minus 2t plus 3, we differentiate that dv dt, we get 240 t minus 2, and t is 3, so we substitute the value of t being 3 to get the velocity. So 240 times 3 minus 2, so 240 by 3 minus 2 get 700, and 240 by 3 get 720 minus 2, we get 718 meters per second squared. So I'm hoping we've learned and will be ready to solve problems on differentiation. Thank you for watching. Make sure you subscribe for more. Have a lovely evening.